Okay, so first, find the element on the periodic table, determine its ion with charge, see if you can find the neutral formula, and then see if you can name it. I'm just going to give you a couple minutes to do that. Are we done? It's still working. Anybody still working? All right, so let's talk about it. Let's get it right. Lauren, what ion does gallium form? Ga3 plus? Did anybody not get that? Or does anybody not understand how we got that? If you don't ask me questions, I can't help you. Okay, so I have Ga3 plus, Charlie, what's the charge on oxygen? You don't know. Where is it located? What group is it located in? Okay, so let's look at this. Let's go back and look at it. We've gone over this a few times, but when we're forming ions, I have a 1 plus, because they have 1 in their outer shell, so they want to get rid of it. I have a 2 plus, 2 in outer shell, easier to get rid of 2 than gain 6. What happens, I jump all these guys, these vary, and if you have the periodic table out that you write on all the time, write in these words. We're going to talk about it in just a minute. Stock system. Then when I come down here, what do these guys do? Group 13. Evan, you're telling me they have 3 electrons in their outer shell, so is it easier to get 3? Brian and Evan are telling me the same thing. They all form a 3 plus. These guys, we said, can go 4 or 4, plus or minus, and then what happens when I get to nitrogen? We start to the negatives, don't we? They have 5, it's easier to gain 3 electrons. So 3 minus, 2 minus, 1 minus. You should have that in your head by now. So now, Charlie, tell me what's the charge on oxygen? 3 minus. There are 2 ways I can go about figuring this out. I can draw them, and I can represent one of them, and I can see that 3 positive does not equal 2 minus. And I can keep drawing these things. To me, that's confusing. If you like to draw it out and count it, like this would be 1. Then if I add another one, I've got 2 more minuses. I still have, that's too many. What happens if I add another one? Now how many do I have? I have 6 minus. What can I do to this to get it to be a 6 plus? Add another one so I can take it times 2. Or, here's another thing you can do. It always works. You might have to reduce, but it always works. If I take 3 times 2, what's the answer? 6. So I write my 6 down here and I say to myself, ooh, what do I have to do to this 3 to get it to be a 6? Multiply by 2. What do I have to do to this 2 to get it to be a 6? Multiply by 3. I like that better. It depends on how your brain works. I don't like drawing all this junk out. So, I need a 6. I need this to be 6. You guys have already told me to multiply it by 2. So Ga2, O, I need a 6. You guys told me I can multiply it by 3. Ga2, O3. Now, the first part of the name is easy. Gallium. Who knows the second part? Well, I drop the N and I add, what do I add? 3 letters. IDE, good. So this is gallium oxide. Anybody get names correctly? Good job. All right, now I'm going to show you something different. I'm going to give you, I'm going to write it like this. 10, 4 plus sulfur. But we have to talk about what that Roman numeral means. Everybody would know this is Roman numeral 4, right? And we don't ever get any higher than Roman numeral 5. So 5 is a V, 1, 2, 3 are just I, and then 4 is IV. So this is Roman numeral 4. When you see the Roman numeral, it's called stock, the stock system. And the Roman numeral tells you the charge. I also know that my first element, or my first ion, should be a cation, and my second ion should be an anion. They're always written that way. Positive is always first. Positive first, and then your negative. So when I look at this, I should know that 10, which is Sn, should have what charge? 4 plus. You got that by looking at the Roman numeral. Plus, I want you to find sulfur, and I want you to find its charge. What is it? Minus or 2 minus? I'm hearing different things. I'm going to carry these over to the other page. So I have Sn4 plus S2 minus. I'm going to show you another trick. It always works. Sometimes you have to reduce, but it always works. If I take my 2, which is my charge, and I make it my subscript, I have Sn2, and if I take my 4 and make it my subscript here, I have S4. And then I have to look at those, and I have to say, can these be reduced? This is a 2 to 4 ratio, which is really a what ratio? 1 to 2. So then I would know my formula is SnS2. That works every single time. To me, it's easier than drawing out charges. It's kind of even easier than the multiplication. But what gets people in the end is they don't forget to check their ratio. If a lot of times, well, obviously, every time if you have an even ratio, almost every time you can reduce it because they're usually small numbers. Yeah, Charlie? I put that here on the table. Because if I look at sulfur, it's down here in group 16, and everything in group 16 has 6 electrons in their outer shell, so they want to gain 2 electrons to have an octet. So everybody in group 16 has that 2 minus charge. Did you write these down when I went through them a few minutes ago? Yeah, so by knowing the group number at this point, you should know the charge. All right, I'm going to give you one more to try. Actually, I'm going to give you 2. I'm just going to let you do it all by yourself all the way through. There we go. That's 2 points. And 3 plus 1. Try those 2 all the way through and see how you do. Raise your hand if you're still working. Okay. Okay, when you're done, stand up. Okay. Charlie, you want to tell me what you got for this one? SR3N2. Do you guys agree with him? Yeah? Stuart, what would you call this? What's N? Can you help him, Sammy? Nitride. Anybody not get that formula? Be honest, because you're going to have to do this tomorrow. All right. What have I not done? Hey, Sarah, what'd you get for iron? Fluoride. Fluorine. F. Oh my gosh. F, E. How did you write it? Did you write your CL and then your 3? Like that? I'm struggling, people. F, E, F. 3? Yeah, okay. You said your 3 before you said your F before, so I wondered if you wrote it out here. All right. How do I say that, Finley? Okay, so here's the only thing you guys need to add, it sounds like. I would say iron 3 fluoride. Because I have to know which iron there it is because there's more than one. For what? Yeah, we would say tin 4 if we were using that. Feel pretty good about that? Because we're going to do it, it's going to get a little harder. How about this? I'm going to give you one and I want you to find its molar mass, then we're going into lab. Let's do barium plus barium plus sulfur. Do the whole thing all the way through. You can do this, it's not hard. So, we're going to go ion, formula, name, so you should have those 4 things. There, now you can see it. Exactly what we've been doing, I just added molar mass on the end. Raise your hand if you think you have a neutral formula at this point. Raise your hand if you're working on molar mass. Okay. Okay, so let's see what we've got. Give me the two ions, Jewel. What's its charge? Okay, 2 plus. And sulfur is 2 minus. Okay, that was pretty easy. Ryan, what was your formula? CAS, good. Probably the hardest one, maybe. Who thinks they can name this correctly? Charlie? Yep, it's barium sulfide. Who's got the right molar mass? Okay, no? Who didn't remember how to find the molar mass? Okay, so let's talk about it. I got to look at the parts. I have barium and I have sulfur to start with. So I go to the periodic table and I find barium. If I find barium, find its atomic weight, 137.327. So I say this is 137.3 grams. Plus, if I go find sulfur, I'll find that it rounds to 32.1. Yes. And then I add them. And when I add them, 169.4 grams. And I would write that as grams per mole. Okay? How many of you got that first time around? Great. Okay. So now, really quickly, on the board, I have a list of all things that are fair game for the quiz tomorrow. We've gone over all of it yesterday and today, except for the groups of the periodic table. That was the one that on that little 12-question thing that I gave you, people had the most trouble with. Up here, the groups of the periodic table, I'm going to cover, so right now, I'm going to expect you to know the names of groups 1 through, I got to think about this, 1 through 12, 17, and 18. So 13 through 16, I'm going to leave alone. Those are the groups that I leave alone. 3 through 12 all have the same name. Transition metals. So group 1 is alkali. Group 2 is good. Group 3 through 12 is transition. Group 17, halogens. Group 18. Okay, there you go. All right, so put that stuff away. Before you leave, if you want to take a picture of the board, you can. We are going to get through. You got to listen to this carefully, because this lab takes a little while. It's super easy, but because everything gets so hot, we do the first part today, and then we'll pick up on it tomorrow. You will get through part 1 today. You will leave your beaker and your ring stand set up. You'll put your water and everything. You'll put your thermometer and stuff back in the corner. Please listen carefully to me. When you are in lab, especially with a bunch of learners, I'm pretty serious about safety and not messing around. So be sure that you are paying attention and you are focused. It is easy to get hurt in one of these labs. People put themselves on fire, people run glass tubing through their hands, and they're not paying attention to what they're doing. So pay attention. If I have to get on you, I will just sit you down and give you a 0. Okay? Goggles, aprons, and then you should be able to get 1 done. Trial 1. All Bunsen burners should still be set. The gas is on. Hair back, sleeves up, goggles and aprons on.